Okay, good afternoon. So there are two more problems I want to solve, and this chapter is finished. But I would say that it would be better if I just give you the problems, wait for you a little bit so you think about it, and I can come back and help you to solve the problem. So there are two problems, yes? So one problem is actually this one. What is the smallest perimeter possible for a rectangle whose area is 16 centimeters squared, and what are its dimensions? Because that's an optimization problem, yes? So I want to wait for you first so that you can take your pen and paper and give it a try. And if you succeed, much better. If not, I can come back and help you, okay? And then another problem, then we are done for this chapter. Okay, did you make some progress? So what we are supposed to do, let us solve these two problems. So what is the smallest perimeter possible for a rectangle whose area is 16 centimeters squared? Okay, so do you remember we had something similar to this before, yes? But in that case, what was fixed? The perimeter was fixed. If you remember, we had a wire, and then the perimeter was fixed. We wanted to find the maximum area. But here the problem is a little bit different. The area is supposed to be fixed and to be 16 centimeters squared, but we want to find the smallest perimeter. Yes? Okay, so what should we do? Okay, so we just try to understand the problem. So we draw a rectangle for ourselves here. So let me just draw a rectangle, whatever it is. And then I know that the area of the rectangle should be 16 centimeters squared, yes? You see that. And then you want to, let me choose P for perimeter. We want to minimize the perimeter. Okay, so what should I do? I need to my target function here is the perimeter. I want to minimize it. But I have to write a formula for the perimeter because I need a function and I need an interval to do that. So for doing that, let me, for example, choose x to be the height and y to be the width, and then if I ask you what is p, you can say that I add x to y and then multiply it by 2, it gives me the perimeter. But again, the same problem that happened before in the previous examples. My target function is not function of one single variable, it contains two variables in it. So in order to solve the problem, I have to get rid of one of these variables. So this is why an extra piece of information is also provided in the problem. So how can I use that? Okay, when you say that the area is 16, this means that the product of x and y is 16. Okay, it doesn't matter which one I eliminate here. So usually, if there is no difference, I prefer to eliminate y. So I divide by x. And I am on the safe side. X is not 0, because if x is 0, the left-hand side becomes 0, the right-hand side 16, so it cannot happen. Okay, so this is my y, and then I will take this y and put it here. So my function, which is p, is equal to 2 times x, but I have plus 16 over x. Okay, now I can safely call it p of x. Yes? And let me multiply the 2 in so that I have my target function as a function of x, so it becomes 2x plus 32 over x. This is my function. Here the interval is a little bit tricky. So can you tell me what is the interval here?
Well, it's...
Yes, Rasmus?
Say it's bigger than 0 and it has no upper bound.
Yes. So it starts from a little bit larger than 0, but there is no upper bound for it. Yes, do you agree with that? because you have one constraint. You want to make the product to be constant 16. Okay? X cannot be 0 and negative, that's a dimension. And then if I increase X, I can proportionally decrease the value of Y so that the product is still constant. So there is no upper bound for X. So in principle, if I ask you what the interval is, an official way of writing is to write, okay, something like that. By the way, that's also used. So X is somewhere between 0 and infinity, and not including. Of course, including infinity is meaningless, but it might be able, we should be able to put it equal to 0, but in this case, no, X cannot be 0, because if X is 0, the left-hand side is 0, the right-hand side 16, doesn't make sense. Okay, so it's a little bit unusual from this perspective. This is the first time that you have an unbounded interval. Okay? But that's also some kind of interval. So if you understood what is going on, you don't have any problems. Okay, so is that understandable? So what I did, I wrote my target function. The target function is the function that we want to minimize or maximize. Usually it contains more than one variable, so you look for some extra piece of information in the problem, use it in a wise way that you can turn your function into a function of single variable, and then you also need to have interval. Whenever you have them, you need to follow the recipe. So what the recipe was, do you remember? What is the first step I have to do? Differentiate, yes? So differentiation of this one, you need to know what I'm supposed to do. This is one exam that you already did. So how can I differentiate 32 over x?
You can first separate.
Separate means?
32 times 1 over x.
Okay, and then what should I do with 1 over x?
You can remake it to x to the power of negative.
Yes, so that's it. So let us do that first. So what we do, I would write that p of x is equal to 2x plus 32 x to the power minus 1. The reason that I did that, because I want to be able to differentiate it. But now differentiation is easy. The derivative of 2x is just simply 2. The derivative of 32x minus 1 comes down, so it becomes minus 32, and I subtract 1 from the power, which is minus 2. And if you don't mind, let me now put it back to make it with positive power. So this is my derivative. Agree? And then I have to solve that derivative. I have to put the derivative equal to 0. So when I put the derivative equal to 0, what happens? I have 2 minus 32 over x squared is equal to 0. Okay, tell me what I'm supposed to do now. I want to solve this equation and find x. What is a good way to do this? Multiply everything by x squared, yes? So I multiply by x squared, it becomes 32. On the right hand side it becomes 0. But I have to isolate x, so I move 32 to the other side, I divide by 2, and then I take the square root, it becomes plus or minus. Minus 4 is not acceptable because this is my interval, so x minus 4 is not acceptable. And then x is equal to 4. Okay, but there is another problem here. Do you remember what was the recipe? The recipe was calculating the derivative, put it equal to 0 and find the possible answer. And then you are supposed to calculate the value of your function at those points as well as the endpoints. But the endpoints are a little bit problematic here. Can you see the problem here? Because I cannot put 0 here. It is in the denominator. So in principle, you should take the limit. What happens when I am getting closer and closer to 0? Yes? So what I do, I take the limit of p of x when x approaches 0 from the right side. Yes? Okay, can you tell me what do you expect for the answer of the limit? Yeah, you rely on your intuition. X is very small number but positive. I put it here. The first part becomes extremely small, but what happens to the next part? It becomes extremely big. Okay, extremely small, extremely big, finally it becomes extremely big. Extremely big means the limit is infinite. Okay, so So it shows you that there is no maximum. And by the way, this is probably the reason they didn't even think about asking you finding the maximum. There's no maximum for this function. Yes, perimeter can be as big as desired. Okay, and then another one, of course, we have to calculate the limit of the function when x approaches to the other endpoint, which in this case is infinity. But again, rely on your intuition. What will happen if x is extremely big? This is your function.
Very big.
It becomes very big because this one becomes negligible this time. This one becomes extremely big. Okay, so a little bit unofficially. So these are the values. Of course, infinity is not a value. And then I also have to calculate p of 4. So if I calculate p of 4, it becomes 2 times 4 plus 32 over 4. So p of 4 is equal to what? 8 and then 8, 16 centimeter. So this is another number that I get. And they are asking for the minimum, the smallest possible. And the smallest possible parameter is 16 centimeters, yes? Because there are 3 things to compare. Plus infinity again, and 16. So I want to find the lowest value, so the lowest value is 16. Yes, is that clear? So that was not a hard problem. The only reason I gave this example because I just want you to understand what happens if you have an unbounded interval. Yes? Okay. If you don't have any questions, let me also wait for you a little bit to solve that problem. So let me read. A rectangular box is supposed to be made by cutting out squares from the corners of a 25 centimeter by 40 centimeter rectangular cardboard and then folding the cardboard to make a box without a lid. What size must squares, what size, I don't know why this is a bad sentence. What size squares must be cut out to produce the box of the maximum volume? And what is the maximum volume? So the question is this. Let me just describe that for you. So you have a rectangular cardboard with dimensions 25 and 40 centimeters, yes? So for example, let us consider that this is my cardboard. I mean, I think it's not a good one. So the ratio should be 25 by 40. So I don't know. Might be it's better to. Oh, sorry. Yeah, something like this. Okay, so for example, say from here to here is 25 centimeters, and from here to here it is 40 centimeters. What we are supposed to do, we are supposed to cut some squares with the same size, of course, from the corners, and then fold these parts up. I hope that you agree. It becomes a box without a lid. Is that understandable? Yes or no? Okay. Now the question is that how much I should cut so that when I have my box, it has the maximum possible volume available. By the way, that's a good practical problem. So assume that you really want to do that. You have a cardboard, you want to make a box for yourself. Of course, you prefer to have the maximum volume so that it contains more things in it. So the question is that 2 questions. How should I do that? It means that how much I should cut. And the second is that, okay, if I respect mathematics, then what is the maximum volume that I gain? You need to answer both of them. It's a good question. It's a little bit lengthy from calculation point of view. I put it in a very bad position, but let me see if I can move that. I don't think it's possible, no. You know why? Because below that, everything is a fake one. That's completely a picture. Yeah. So I cannot use that feature now. Anyway, so I want to wait for you a little bit. Okay, how much I am supposed to cut is not clear for me. I need to find that. So if you don't mind, let me call that x. So I have x from here, x from there, x from here, x from here. So these are all x's, yes? We don't know how much we should cut for the time being. But what is my target function, yes?
So, well, the entire function as I wrote it was, I need to find the volume. So, well, first I need to find the volume. It's the area times the height. And first I know that x is my height because that's what I'm going to hold up. And my area is going to be 40 minus x times 25 minus x.
No.
No?
Not 40 minus x.
40 minus 2x.
40 minus 2x.
Yeah, 40 minus 2x times x times 25 minus
2x. Yeah, that's correct.
That's
So if I ask you what is this length, so this length is equal to 25 minus 2 x's, yes? Because the whole width is actually 25. I take one x out from here, I take another x out from here, so what is left for me is 25 minus 2x. For the same reason, if I ask you what is this length, that is how much? 40 minus 2x. And then you see that because this is also x, when I fold it up, that x will play the role of the height of the box. Yes? So it means that the volume that is my target function, the volume is equal to the area of the base, which is the product of these two, multiplied by the height, which is just simply x. If you have questions, please let me know. So what I do, I multiply 40 minus 2x, and I multiply 25 minus 2x, and then I multiply it by x. Then, of course, I get a function only of x. By the way, this is one of those problems that I didn't need any extra information. I just get v as a function of one single variable x. But what is the limitation for x?
It can't.
Of course, the minimal value is probably 0, but if you don't cut anything at all, you don't have the box in principle, you have just the plane. Or we can say it is a degenerate box or whatever, okay, yeah.
It can't be bigger than 12.5?
Yes, because on one side the limitation is 20, but of course it cannot, yes, you are right. So it is 25 over 2. Or this. Do you agree with me? Because this should be positive, this should also be positive, otherwise I will not have this one. The limitation here is less, so here x should be less than 20, here x should be less than 12.5. I need both of them, so the common part is just 12.5. And then you know what to do. This is your function, this is your interval, so you have to be patient and calculate it. So how should I do that? I need to take the derivative, but because you haven't studied the product rule, so there's only one way for you to deal with that, and that's multiplying first. So what I do first, I simplify my function. V of x is equal to, so I multiply this by that first, which becomes 40 times 25 is 1000, and then minus 80x, and then minus 50x, and then plus 4x squared. I simplify these two in my head, it is minus 130, and then I multiply x in. So finally, the v of x that is simpler to work with, it is 1000x minus 130x squared, and then finally 4x cubed. And then I differentiate, of course. The derivative of v is simply 1000 minus 260x plus 12x squared. Oops, these are really big numbers. Okay. So I put the derivative equal to 0. Okay, so we have to suffer a little bit. So this means that 12x squared minus 260x. Of course, you can use your calculator, but let us try.
Wait, how?
Yeah?
Or I'm confused because I used the common term identity to expand
That's also correct, yes.
but I don't know how you got 130.
80
Well, I
minus
mean, I
50,
guess, or does it make sense?
minus 80 minus 50.
No, because in the common term identity, I need to add them
Mm-hmm.
and then multiply them by the common term. But in the common term, there is also 2.
Sorry, I
Yeah,
forgot the 2x.
yeah. Okay, but what is your suggestion for me here? Do you think this number is not divisible by 12, of course. But if I want to simplify life a little bit, I divide by 4. Is it divisible? Yeah, it is divisible by 4. So let me divide by 4 to make life easier. So this becomes 4x squared, and then that one divided by 4. If I divide by 2, it's 130, so it's 65, yes?
3x.
And then it is 250. Am I right?
Balak.
Yes?
3x squared.
12 divided by 4 is 3.
Ah, okay, sorry. Thank you for letting me know. Okay, so this is 3, yes? Okay, so this is equal to 0. And then I have to solve this equation. So x becomes b, which minus b is 65, plus or minus 65 to power 2 is 4225, yes? Yeah. And then minus 3000. 4 times a times c, yes? And then divided by 2 times a, which is 6. Then it becomes 65 plus or minus a square root of 1225 divided by 6. But the square root of 1225 is 35, yes? So it's plus or minus 35 and then divided by 6. And then I have 2 answers. One answer is 100 divided by 6, which is 50 divided by 3. Is it acceptable? Fortunately not. Yes? Because that would be problematic, you know? This number does not lie here. So we throw them away. We throw that away. So not acceptable. And then the other one is 30 over 6, which is 5. And this one is acceptable. But then I need to calculate v, my function, at this endpoint, at that endpoint, and this only number that I got. And I hope that you immediately see that what is v of 0? Is 0. Because if you don't need to work with the hard version, you work with the simple version. When I put 0, x is 0, so everything is gone. When I put 12.5, this last part becomes 0, but again, everything becomes 0. So v of 0 is 0, v of 12.5 is also 0. I have to calculate v of 5. But if I calculate v of 5, this becomes 30, this becomes what? 15, yes? And then if I multiply them, if I multiply that, it becomes 2,250, yes? 2,250 and then cubic centimeter. You can check my calculations using calculator, it doesn't matter that much. But hopefully you realize that between these 3 numbers, of course this is the maximum. So this is the answer to the second part, what is the maximum volume? But what should be how should I do that? How should I achieve to the maximum value? By cutting how many centimeters, yes?
I think you miscalculated.
Oops, yes, where?
It's supposed to be 5 times 30 times 50.
What? Here?
No. And in the original equation, if you, instead of x, if you put 5, you have 3 terms there that you need to multiply.
Yes, so here is 5, and then here is 30, and here is how much? 15. Yes? What I did, I multiply these two first, it becomes 150 times 15,
Ah, yes.
and then it becomes 225, and there is a 0.
My mistake.
Yes? Yeah, okay. So this is the number. Okay, so if they ask about the maximum volume, this is the answer. But how should I achieve the maximum possible volume? By cutting 5 centimeters from each side. By the way, it's a very nice problem because it is. So you use mathematics to solve that problem. It was not easy to guess. We should cut 5 centimeters. Yes? Okay, any questions? Okay, so this is the end of this chapter. So after the break, we will start the interesting topic of integrals, I think. And now we have trigonometry. Okay, so no questions? Thank you.